thank you everyone for joining us and staying here for the last session. So maybe we'll start with a small introduction first and talk about AI, automotive, and what does that mean, and what are the challenges facing automotive companies looking at autonomous driving of the future. So a few words about myself. So my name is Ruby. I'm leading the Hyundai CRADLE activities office in Tel Aviv. So Hyundai CRADLE is the platform that Hyundai established to access innovation outside of Korea, to connect innovation into the mothership inside of Korea. So the first CRADLE that opened up was in Silicon Valley, and with great pride, Hyundai decided that its second CRADLE office would open up here in Tel Aviv. That happened like about a year and a half ago. And since then, we opened up more offices in Berlin and in Beijing as well. So the objective of the office here in Tel Aviv is to focus around AI, cyber activities, deep tech. And to date, we have made in Tel Aviv 8 investments in companies and have been doing numerous POCs with companies in the ecosystem. So in addition to myself, we have here a team also, Kobe and Lior, if you could raise your hand. So we have here as well, here with me today. And yeah, you keep raising your hand. Yeah, maybe you want to join the team. That's the idea. Okay. So that's us here in Tel Aviv. And with me, we have, for the first time, visiting Israel. So thank you for joining first time in Israel.
Thank you.
He likes it a lot because in Korea now it's 0 degrees Celsius and he has like 24, so he lucked out. So Dr. Baratoff, Greg Baratoff, could you say a few words about Mobis and what Mobis does and what you do?
Okay, so welcome everybody. It's been, as Ruby said, quite nice to come here, not just because of the weather, very interesting topics being discussed. I personally moved to Korea about two years and a half ago to join Mobis and I had the ADAS and autonomous vehicles center over there. We have a few centers in Europe and China and the US as well, but the one in Korea is the biggest one, and that's from where we try to also put out our fingers and try to get hold of innovations. And Tel Aviv is definitely a place where we're hoping to find some good technologies, good ideas.
Awesome. So hopefully we'll have a lively discussion and leave some time for Q&A at the end. So hopefully you'll find this topic interesting. So the first topic we wanted to talk about was about sensors. So, you know, everyone has been talking about AV and sensors and the perception that you could stick a couple of sensors on top of a car and then it'll enable autonomous driving is a little bit inaccurate. So the fact that you need to put multiple sensors of different types and in real time be able to make decisions is a pretty complex technology challenge. So this is where AI should support that type of activity. So the first topic we wanted to talk about was about object detection. So maybe you could say a few words about object detection, real time, how does that happen, challenges?
Yeah, okay, so I think the way we approach it is one is obviously the AI way, then we also use the more traditional kind of geometric computation style structure from motion for cameras and SLAM, probably familiar with all that. And of course the AI is the newer methods, deep learning, that we apply to basically classify objects, detect them by classifying them and track them. The two approaches are kind of complementary. One interesting thing is that some people have been starting looking at it, is that even if you apply geometric approaches, there's still, let's say, a bunch of parameters that need to be optimized, and so people have used at least machine learning or AI as well to tune geometric computation as well and fuse it with the typical AI-based approach. One of the issues we have for sensors is that, especially if you apply AI approaches, that there's a lot of data to be collected, because the environment is very diverse. daytime, nighttime, all kinds of weather conditions and so on. So it required, one of the major tasks and difficulties we have is collecting data and trying to decide when to collect, where to collect, and how much of it to collect.
So talking about the sensors, how much do you trust the sensors? Like, isn't that challenging?
Yeah, so that's a good question. I think a difficulty that arises specifically for products is that you need to be able to detect when the sensors are not reliable anymore. So there are many, let's say, you could say that many of the problems have kind of been solved in academia already, how to train networks and collect data for them. But in the real world out there, and especially under bad weather conditions, you need to know when your sensor is becoming unreliable, when your AI doesn't have information to extract from the scene to give you back a reliable signal.
And when you have one sensor telling you A and the other sensor saying B, so how do you manage that? Like, what's the...
So so that obviously you want to do some kind of sensor fusion or sensor selection. So basically, if you have a way to detect when a sensor is reliable, when you can trust it, then you can either use that sensor or you can even fuse it with another sensor. One of the difficulties is that in sensor fusion is not the way to actually fuse it. I think that there's a lot of theory on that, on how to optimally fuse sensors, but knowing when you can trust a specific sensor, knowing when data that one sensor provides about an object is somehow complementary to what the other sensor provides. And some of the challenges are to be able to detect when two sensors provide information that does not agree with each other. So what do you do in those cases? All these problems are not necessarily so big when you work on like level 1 or level 2 type of autonomous driving systems, but when you go to level 4, basically there's no excuse. You have to basically address every single scenario that's out there, and if you can't address, you have to kind of try to improve your system and fix it and find a way how to best fuse it.
Indeed so. So talking about the fusion, so you have multiple sensors in the car, and you need to compute all of those different sensors in real time. And one of the questions is, so where do you do that computation? Like, do you do it on the cloud? Do you do it on the edge? Is it a hybrid? What do you think is going to happen at the end?
So I think basically any kind of sensor information that you need to decide whether you can avoid a collision, an accident, anything that can bring harm to the driver, to the passengers, to people out there, or even just damage the car or property. From my point of view, that has to be on board in the vehicle, because if you would rely on the cloud, the communication to the cloud and back again, you would be exposed to, a breakdown of the communication. And if that would endanger, lives or create accidents, that would be an issue. So there's a lot of talk about 5G being, very high speed and high bandwidth and low latency, but I think there's still non-negligible chance that a communication breakdown could happen. So I think you need to have the major sensors like cameras and lidars and radars on board to be able to act in real time autonomously in the vehicle.
So guys here working on small neural networks with small computation resources or small memory would be interesting for you guys to hear about.
Sure. Yeah. I mean, anything that allows us to do all the neural network and other computations on board is very welcome. And I've seen a lot of startups working on various aspects of that problem. So on the one hand, trying to shrink, for example, neural networks in size, by trying to keep the performance more or less the same. That's one aspect. Another way is obvious to have chips that are more efficient and can just compute more inferences per second than let's say an expensive GPU would, for example.
Indeed. So that maybe moves us to the next topic that I wanted to ask you was another way or another constraint that exists is the algorithms themselves and how much training needs to be done and how can you optimize that. And training in the automotive is indeed a bit difficult because there are a lot of edge use cases. So there are many, many use cases that are need to be trained by the algorithms. If it's someone passing the road or multiple objects that multiple sensors are looking at, and you need to train the algorithms in such a way that are able to reach the optimal decision. So Greg, from your perspective, maybe you could share a little bit about the difficulty of this task of algorithm training and where AI can potentially support, the level 4, level 5 requirements.
Yeah, so I think especially with respect to level 4, level 5, the expectations are very high. Again, the theory of learning and training neural networks has advanced quite a bit, and in practice also there's a lot of good tools to do that. Where I have seen only initial theoretical work is answering questions like, how do I sample my state space? How do I select the data for training? How do I detect when there's a certain area of my state space that I have not covered yet? And when, in general, basically something that tells me when I've, let's say, collected enough information. That's one aspect. The other aspect is, making sure that relates to the real-time requirements, again, is how do I know whether the architecture I have chosen for the neural network has sufficient complexity to actually allow me to solve my problem, right? So especially if we're talking about kind of edge devices and limited computation, if for somebody who's planning to build a level 4, level 5 system, you need to know whether you have dimensioned it properly. Yeah. So I think there's a lot of good theoretical work out there. I've seen some also here today and at previous conferences. So any, let's say, efforts to bring those theoretical approaches to actual practice would be very welcome, because these are very practical problems we need to solve, and any kind of question related to data and data labeling, results in a lot of expenses for the collection and selection of the data. So that's definitely an area that needs to be looked at.
So what does Mobis actually do? So with labeling, so a lot of startups here, they outsource that to people out in India, Indonesia, that do the manual labeling. So what is the approach that Mobis thinks is the effective one?
Yeah, so we do that as well, like everybody else. But I think that in the long run, only addressing it via supervised learning is not necessarily the right way to go. There are some initial approaches to use unsupervised learning. So basically, let's say you have a set of label data, but then you have a huge, try to collect a much bigger set of data that you kind of just record, but you don't have to label. And as I said, there's some algorithms out there, people working on that. Hopefully, also possibly some startups and companies working on that allow us to leverage data that we just record in raw form without actually having legions of people have to label it.
Indeed. So, like as the one that's leading the ADAS plans and development inside of Mobis today. So what are the main challenges that you are dealing with? And maybe some people here in the audience can support your activities that you're looking at now.
Yeah, so I think I mentioned some of the topics. So basically, how do you do all the data management? So we're applying very, let's say, pragmatic ways of collecting data. You try to think of all the possible objects you want to cover and all the different poses they should be in and all the different weather conditions they should be in. But I think we could profit a lot from having tools that help us decide which data to select or which area, let's say, to go to collect more data, to increase the diversity. That's one thing. Then the other thing I mentioned, the use of unlabeled data. I think that would be really a very big thing for us, probably for others as well. So I would think that there's enough push in the industry to work on unsupervised techniques, or at least semi-supervised techniques where there's a mix of labeled data and unlabeled data. And then, in addition to that, of course, anything that allows us to operate these systems in real time, such as AI chips or techniques to shrink network sizes and so on.
From the hardware perspective, so you touched about that briefly, maybe just expand a little bit more. So hardware, is there anything specific that you think should be developed for the automotive, or could automotives use off-the-shelf type of chips that are out there for data centers?
Yeah, so there's a little bit of a difficulty in automotive. There are pretty strict requirements in terms of the, let's say, the automotive qualification requirements. Cars usually have to ensure a very long lifetime under very harsh conditions. For example, the temperature range over which a chip has to be qualified in automotive is between -40 and +85 or +105 degrees. So these are additional requirements on these chips that kind of possibly a data center chip does not have to satisfy. So one of the issues we have is that companies who are trying to get into automotive from another area at first are, let's say, a little surprised by the additional requirements they have to fulfill, and that usually requires them to redesign a chip. That's one side of it. On the other side, maybe there's something the autonomous driving industry can do as well to try to maybe accommodate their designs to use these very powerful chips that are used for data centers, and basically put, in the system design, put, other chips around that ensure the safety of the system, and can possibly indicate when, let's say, conditions are reached that maybe, high temperatures or very low temperatures when the data center chip can't operate, and detect that and kind of go into a degraded mode.
Awesome. So thank you, Greg, for now. So just wanted to open it up. Questions? Anybody? Ideas? Somebody wants to pitch a startup? Yeah.
Yeah.
So the question was about radar and about and the transition.
Okay, so radar, I didn't mention radar too much because kind of for me it's clear that radar is part of the sensor package for ADAS and also for autonomous vehicles. Each of the sensor technologies itself has to develop further. And that's specifically also true for radar. What you see nowadays is that a lot of the radars are moving from a, let's say, fairly simple type into what you call an imaging radar, where the data you work on looks very much like a camera image. So radar, I think, also because it's just a completely different modality that works when maybe you have bad visibility or something, is crucial, I think, to both ADAS and AV systems. And the transition from ADAS to AV, I think, requires improvement on several fronts. The sensors is one thing, so all the sensors and sensor modalities have to be further developed. You see that in cameras, it's a question of maybe more resolution. Also, there are various types of cameras. They're like not just passive cameras, but infrared cameras, thermal infrared, etc. Those can be very helpful for nighttime. And we probably witnessed also the explosion of the activity in the LiDAR space. So many different LiDAR companies. That is still very dynamic, kind of a Wild West scenarios. You know, I think there are like 50 or 60 LiDAR companies out there. Many of them probably won't be around for in a few years, but many things are happening there. And so far, at least in the initial, I think, you know, there are different voices, but most companies agree that at least in the initial 5 to 10 years, LiDARs are necessary for autonomous driving. Possibly later, I don't know, some people think radar can take it all over, or camera, so we'll have to see about that.
Yeah, Elon Musk said, you know, about a month or two. No need for LiDARs, but I think it was just trying to be controversial. But price is also an issue, like Greg didn't touch that, but the question is if you use a dedicated chipset to do the computation on the radar. If so, yes, and if not required, so just as an FYI, Hyundai invested in Middlewave. It's a US-based radar company that uses off-the-shelf chipset to do its thing. So, any other questions? Yeah, on the top.
Yeah, okay, so Hyundai is a company that values security very much, so we have a on-premise solution, but we use, you know, we don't have any special solution. We also use NVIDIA, you know, DGXs or similar to train. Just last year we invested to be able to train all the different networks we're working on. The difficulties are what I mentioned earlier. I mean, how do you collect all the data that you need? And the training methods, I think there are a lot of training frameworks out there that can be adopted. I think there's not so much difference between the companies. I think now it's all moving into a direction where it's the amount of data and the type of data that you collect that makes the difference. So for level 4, I would say the thing is really the system doesn't really have a clear boundary that's defined by requirements, right? It just says it has to work out there. Maybe it will tell you, you know, only on certain roads on a geofenced area, but still there's so many unexpected things that you couldn't have thought of. You have to go out and collect the data and then retrain.
Just adding on that, so, you know, there are some Israeli companies that also produce synthetic data. So the companies that do the simulations with synthetic data is also something that Hyundai's R&D teams are looking at, as well as a potential, you know, bypass to that problem. Any other questions? Yes, please.
Yeah, so actually, so far, most of the system have been using high-level sensor fusion, where basically you do object detection, classification, tracking in each sensor individually, and then try to marry the high-level representations. People have started working on what you'd call mid or low-level fusion, so where you maybe could imagine some objects being occluded or in other ways not recognizable as a full object by a camera, for example. And you'd have, so you could maybe detect part of the object. And then you could have the radar, for example, seeing another part of the object, and then you kind of put those parts together and say, okay, in some, you know, it makes, I don't know, a vehicle or a pedestrian. And then also some approach, especially I think for LiDAR and camera, you could also try to do pixel level fusion because they're both kind of give you a 2D image. From a performance point of view, I think there are good arguments to go to mid and low level fusion. But there's one aspect that needs to be considered, and that's the kind of safety or redundancy aspect. So let's say if you, in the classical high level fusion approach, each of the sensors detects the object, and if it detects the object as a whole object, it's kind of a confirmation of its existence. And when you fuse them, you have, in a way, redundancy, and that gives you additional, let's say, confidence about the existence of that object. If you do mid or low-level fusion, you lose that. So you have to say, well, if I detected this part of an object in this sensor and another one from the other one, I need to have some confidence that they belong to the same object. So that's kind of an interesting combination, a trade-off one has to make.
Yes, please.
So we have, let's say, systems of different levels, so level 1, level 2, level 3 systems. So we have level 1, level 2 systems out there. We're working on a mass production series program for level 3 currently. During development, let's say, we use shadow mode a lot. Yeah, we just basically collect the data and then later simulate it in our on-premise cloud to see what kind of driving behavior would result from that, especially in the early phases when you're not fully sure that the perception works as you want it to. You need to be a little bit careful to hook it up to the actuation right away. Currently, we do that in development only, but in more and more. You have OTA entering the cars, so that's something that allows you to basically run in shadow mode and then later update it.
Yeah, another thing to add on that, so you're seeing more and more collaboration between large players. So Mobis announced a collaboration with the Russian-based Yandex to do autonomous vehicles, so there's joint development going on there. And Hyundai announced a few weeks ago a big collaboration with Aptiv. So it's a $3 billion JV with Aptiv that they also would collaborate around autonomous vehicles. So all the other car OEMs are also doing this. So you're seeing consolidation, collaboration amongst the different players. Yes, please.
Yeah.
Yeah, so it's not a full stack, end-to-end type of thing. There will be, I guess, chunks that, go out to that JV. There are chunks that will be done by Hyundai. There are chunks that will be done by Mobis. So it's a work in progress that is currently being discussed among the companies.
Yeah, so maybe precise that a little bit. So the JV is about software, right? So the software stack. So the JV does not cover any hardware, which could include AI chips and things like that, and does not cover the sensors themselves. So it covers the software that runs on a central ECU. So there's, and as I mentioned earlier, both on the sensor side, new technological developments are needed to provide better sensors for the level 4 systems. And on the central compute side, we need chips that can basically compute, deep neural nets of various sizes. So I think in those areas there will be activity in the startup area.
For sure.
Excuse me? Yeah. Yeah.
I think it's still premature to make sense.
Yeah.
There's a lot of development. So I think somebody in the previous presentation said that maybe 90% of algorithm development does not go to production at the end. So there's a lot of trial and error going on. And, I think that the jury is still out what will happen at the end. Anybody else? I think we enjoyed the fact that we have one last question. Yeah.
So you mean interference between radars on different vehicles? Yeah. So there are different approaches. So I think the current radars that are out there, most of them, I think, use some kind of something like a frequency hopping or shifting approach, where they can actually send out the millimeter waves with different center frequencies, and they have a way to detect that there's interference, and then they'll try to hop to another one that allows you to scale to a certain number of vehicles around you. I think in the future that possibly might not be enough. So a very good point you raised there. But there are newer technologies, and that's one aspect why radar technology also has to evolve. There are technologies based on phase code modulation, etc., that will allow you to be completely interference-free.
So, Greg, I think we enjoyed the fact that we were on the last panel, so we didn't have a moderator tell us that our time is up. So it gave us some more time to ask from the audience some questions. So I think it was hope to think that it was a lively discussion and also practical. And just to summarize, Mobis currently is not here in Israel on a constant basis, but it's something that hopefully, Mobis have plans to be more active in Israel in the future.
Yeah, so we in addition to CRADLE as a Hyundai entity for innovation, Mobis also has a similar lineup of innovation labs, and one of my colleagues is here to see whether we can open up a lab here as well in parallel to CRADLE, with a stronger focus on the sensor technologies and compute technology, AI chips and things like that.
So I guess a good way to summarize this is to say to be continued till next time.
Yeah, I hope so. Yeah. So thanks also from my side for all the questions and for staying for the last session as well.
Thank you, everyone. Thank you for joining.